Okay, let's get started. So, now, good, okay. So we're starting a new chapter. We're starting trigonometry, and that's good because it starts off pretty easy. Yeah. Now, to get started, just a quick refresh here. We know when we are measuring angles for one full circle, we have 360 degrees. But there is another way to measure angles. We can use 360 degrees or 2 pi, what are those called? 2 pi radians, yeah. There's another way to measure angles. In fact, there is a third way as well. Does anyone know the other unit for measuring angles?
Degrees? Yeah.
We have degrees. We have radians. Yeah, I guess so. 400 gradients as well. That's the other one. If you look at your calculator has 3 modes on it: degrees, radians, and gradients. The 3 different ways to measure angles. Have you noticed that your calculator has 3 angle modes? Yeah. We concern ourselves with these 2. Degrees or radians. So 360 degrees is roughly 6.28 radians. But we want a way to convert precisely, so this is how we can do it. If we want to go from degrees to radians, all we do is we take the degree and we multiply it by pi over 180. If we want to go from radians to degrees, we multiply by 180 over pi. So for example, 30 degrees in radians would be 30 times pi over 180, which is pi over 6 radians. And you can write that as a decimal if you like. What would that be as a decimal roughly? 0.5? What's 0.5? 236, so 24, is it?
Yeah.
Roughly, radians. And let's say I want to go the other direction. Let's say I want to convert 1 radian into degrees. So that'd be 1 times 180 over pi. What's that? Roughly 57 degrees, is it?
Yeah. 57.30.
Now, what is so special about using radians? I don't know if anyone knows this. What's so great about radians? Like, we have degrees, so why do we need radians? Yeah?
It's easier to use it in some cases. Like
Yeah, but what is a radian? Like, what's so great about a radian? Something to do with a circle for sure, yes. Do we know what it is? No?
yeah, like 2p.
Yeah. What's so great about 1 radian? Like, I could draw...
Well, radian is half, so
Not
oh,
quite.
it's p, sorry.
Not quite. Look. Well, okay, it's not obviously to scale. But there's 1 degree. What's so great about 1 degree? Nothing really. What's so great about 1 radian? Does anyone know? No? So, 1 radian, if you have a circle of radius r, that's an r, and this angle here is 1 radian, then you know that this length from here to here will also be 4. So that's what's so great about a radian. If you have 1 radian in a circle, then you know that this length here will be the same as the radius. In fact, that's the definition of what 1 radian is. It's the angle you need in a circle so that the arc length is equal to the radius. I'm sure some of you have seen this before. No? Are you sure? Are you really?
Yes.
But you've seen radians?
Yes.
Okay. Did you see this before? No? Did you see this before? You mentioned circle. So, did you see this before? Yeah? Over here? No? No? Okay. They're not going to ask you, in the physics exam they do, but not in the maths exam for the definition of a radian. But that's, if you just want to draw it, it gives you a good picture of how big a radian is. It's the angle you need to make 1 radius in the arc length. Okay. Can I scroll down? Yeah? Yeah? Actually, just before I go on, does anybody know why this is 360 degrees? Like, what's the... Oh no, I mean to say, why do we break the circle up into 360 pieces? Any special reason it's 360? No? The reason for 360 is because there are many numbers that divide into 360. So if you want to break it up in half, that's 180. A quarter, that's 90. You know? Eighths, that's 45. You can have 30, you can have 60. That's why 360 is used. It's easy to break it up. Okay, so the next thing we will do is something which you all know from, I'd say, elementary school. Pythagoras Theorem. And Pythagoras said c squared equals a squared plus b squared. Or to be more precise, if you have a right angle triangle, then c squared equals a squared plus b squared. What's also interesting is it goes backwards. If c squared equals a squared plus b squared, then that means you have a right angle triangle. I think people forget this, that it goes both directions. So if you have a triangle and you know that this is 3 and this is 4 and this is 5, and I ask you, is it a right angle? The answer is yes, because 5 squared equals 3 squared plus 4 squared. But most of the time we're using it the other way. We know we have a right angle. We know we have, say, this side and this side, and we want to get this side. So we would have 5 squared plus x squared equals 13 squared. So x squared is 169 minus 25. So x squared is 144. So x is 12. Okay, but I think it's worth reminding you that it goes both directions. That's Pythagoras theorem there. Does anybody know what this symbol is called? This one? Reversible? No. No. No, nobody? Well, let me take it back a step. We know this symbol. What's this one? Not quite equals, because that's equals.
It's an arrow.
Implies. Implies. Okay, we don't know our names, that's okay. This one is called if and only if. That's the name of this one. I think you should make note of that. Okay. You got that? Yeah. So I'll just give you just a small Pythagoras question before we go on. So I'll say that side's 2 and that side's 1, and I want this side. So I'll just give you 1 minute to give me that side. Yeah, it's root 3. Yeah? Is that okay with everyone? Root 3? Yeah, that's easy peasy stuff. Okay. And lastly, I want you to tell me is this right angle or not? No, because 64 does not equal 36 plus 49. Okay. Now, the next thing to have a look at is our ratios. So this angle here is theta, and each of these sides has a name. So this side, this side, and this one. They're the 3 sides of the triangle. There are how many ways to compare the sides? So for example, one comparison you could make is you could compare the opposite, you can compare that with the adjacent, for example. Okay, or you could compare the adjacent with the hypotenuse or whatever. How many comparisons can we make altogether? More than this? 9, but only 6 of them really make any sense. Okay, because if you think about it, you can compare the opposite with the adjacent, you can compare the opposite with the hypotenuse, and then you can compare the opposite with the opposite. But of course that one doesn't really make any sense to be doing. You compare the adjacent with the hypotenuse, you can compare the adjacent with the opposite, and the adjacent with the adjacent, which again doesn't really seem useful. You can compare the hypotenuse with the opposite, the hypotenuse with the adjacent, and the hypotenuse with the hypotenuse, which doesn't seem useful. The 3 we're going to have a look at: opposite compared with adjacent, opposite compared with hypotenuse, and where's my other one? Adjacent compared with hypotenuse. This is what we'll look at. But I think some of you might know this, that the other 3 guys here, they also are useful too. These ones form sine, cos, and tan, which you probably have heard of before. And does anybody know what these 3 guys are? Cosecant, cosecant, and cotan, which we'll have a look at in the 2nd semester. So, sine theta, which one's that? Opposite over hypotenuse. Cos theta, adjacent, and tan theta, opposite over adjacent then. Okay, let's have a look at some simple examples using these. Write those down in case you forgot them. And you all know the word to remember these?
Yes.
What is it? Yeah. You've not seen this word before?
No, I've seen that. Just need to remember the triangle and this one.
Whichever way you prefer to remember it. So the reason sine, cos, and tan is useful is because it can give us missing sides and missing angles. So let's look at an example of each. We want a missing side, and then we'll want a missing angle. Can I scroll down? No? Got that, yeah? I can scroll down? Yeah. Now let's take this example. This is 90. Oh, well, I drew it, but I didn't say it. This only works if it's right angles. Everything in this lesson is for right angles. Okay, so let's take this example. Let's say this is 60. Let's say this is 2 and this is 4. No, sorry, that's silly. That's 2 and this is x. Why can't I use Pythagoras?
Because
Yeah, we don't know the hypotenuse, yeah. In other words, we only know one side.
no, you don't know the angle though.
But I know the angle, so that means I could use the sine, cos, or tan. Which one would be most useful here? Tan, because it has an opposite and adjacent. So this is an easy one to get started. You can say tan 60 equals x over 2. So that implies that 2 tan 60 equals x. So as a decimal, please, what's x roughly?
3.464.
3.46 then, units. That's okay? Yeah? Now, here's a different example. Let's say this is 1 and this is 2. And let's say I want, or let's make it a bit different. Let's say I want the angle up here, theta. Now I can't use Pythagoras because Pythagoras never tells me angles. But just be careful. Do I want sine, cos, or tan? Yeah, because the one is opposite and this is hypotenuse. So you can say sine theta equals 1 over 2, which equals 0.5. Now, do we know how to switch from sine theta to theta on the calculator? You type in, second functions, shift sine. Sine inverse 0.5 then on the calculator. This is the theta. So what do we get here? 30 degrees. Okay. Can I scroll down? Oh, and just to be clear, this is a ratio and this theta is an angle. That will be important for the next example. So without using the calculator, I want to calculate this. Sine cos inverse 5 over 13 without using the calculator. So firstly, the cos inverse 5 over 13, is that a ratio or an angle? What does cos inverse give me? An angle. And then the 5 over the 13 is a ratio from a triangle. So let's draw this triangle. 5 over 13, cos inverse. So what is the 5 representing? Which is this side. And then 13? Yeah. So the cos inverse is this angle. And then I want the sine of that angle. So I need to know this side. What's this side? Yeah, from Pythagoras. So the answer here is 12 over 13. You don't need to use the calculator for this one. I'm going to give you one to try, a hard one. I'll keep it similar. I want you to calculate sine cos inverse x. Any answers? Say again?
1 minus x squared.
Is there a square root on that? I thought it might.
1 minus x.
It's 1 minus x.
Maybe. I thought there should be an x squared in it. Let's have a look, yeah. So look, this is sine cos inverse x over 1. Yeah? Because x is just x over 1. If you draw the triangle, this side here is x and this side here is 1. So Pythagoras says this side is 1 minus root 1 minus x squared. So then what is the sine of this angle? Well, it'll be this over 1, won't it? Which is, yeah, root 1 minus x squared.
Can we simplify that?
Root 1 minus x squared? No. And if you tell me that's 1 minus x, then your holiday was too long. Because that does not cancel like this.
Why? Well, why? Why not?
Dang. All right. Right. Watch carefully. 4 squared minus 3 squared is 16 minus 9, right? Which is 7. Root 4 squared minus 3 squared should be root 7, right? This is all true, isn't it? If I use your rule, root 4 squared minus 3 squared would just be 4 minus 3, which is 1. And does 1 equal root 7?
No.
Doesn't work like that. Yeah? For the same reason, a plus b squared is not a squared plus b squared. Right?
Yeah.
Yes.
Oh, okay.
Yes. 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 Okay. Let's have a look at a harder one now. Let me give you a tough one. Now, give me the x. Try that for a minute. Got an answer?
2, 4, and 2, 1.
It's 1.
Is it? Well, let's see. We'll get this side first. I'll call this side h. So what's the best way to get h? Tan, isn't it? Tan 20 equals h over 1. So in other words, h is just tan 20. And what's tan 20, please?
0 point something. Yeah, 0.364.
One more decimal, please.
Yeah, because it's 9.
49.
It's 0.36397.
Okay, we'll go with 397 then. Okay. Now, what should I get next? I should get the hypotenuse here. I'll call it L. What's the best way to get L? I could just use Pythagoras. I could say L squared equals 1 squared plus 0.36397 squared. So what's the L?
Why didn't we use cosine straight?
From what step?
From first one to find L straight away.
I could have, I suppose. Yeah, I actually could have skipped finding the H, couldn't I? Okay, that doesn't matter. I'm here now anyways. What's the L? 1.064. Yeah. And then finally, how can I get the X? Yeah, Pythagoras. X squared equals 1.064 squared plus 2 squared. Yeah, what's it? Square root. 2 point. So if I do 3 significant figures, it'd be 2.27. Yeah? Yes? Yeah? Okay, that maybe was too easy for you. Let me give you a harder one. That's a hexagon. You know this shape, hexagon? Yeah. How tricky do I want to make this? I'm thinking what I'm drawing. Do you know what I mean when if I draw a little dot here? What am I saying? Same angle. Yeah. That side is 2 meters. Okay. I've got a good one for you. Tell me the length from here to here. There we go. Now that'll have you thinking for a minute. blue line.
No, the black to the orange.
Orange?
Red. Which line?
This one.
This red one?
Red. Yeah, red with black.
This?
No. It's this way.
This?
Yeah.
Oh, are these like lined up?
Yeah.
No. Oh, I see. You're saying, is this like one continuous line?
Yeah.
No, not necessarily. I can draw it a little bit different to make it. There now. Alright, I'll make it taller then if that'll help you.
All right.
Better? Okay, there you go. Actually, you know what? I'll make it a little easier for you. No, I'll give you some more information. I'll give you. All right. Okay.
Why?
Okay. I'm concerned I didn't give you enough information, but you seem like you can find an answer. No, I'll tell you. I'm sorry.
Yes.
This angle here.
It's 40.
No, I'll just pick a number. We'll say it's 60 and 60. Oh no, you're right. Sorry, that's too easy. That's too easy. Sorry. Oh, fine. 60, 60. Fine.
So all sides are equal.
Yes, yeah, okay. Go ahead now. I made it so easy now. Finish it.
If it is 60 and the line is straight, the line is straight line.
No, it is. I accidentally picked 60. I should have picked something harder.
Dude, this is all you did. Yeah, if I don't pause, I would have fascinated. Of course you would have. But I would have though.
Did you get an answer?
I was getting one. I was on the last step. Actually on the last step.
All right, let's have a look. So, as you figured out, Aziz and others too, because this is 60 and this is 60, then this here is 60. And what triangle is this now? Equilateral, which means this side is 2 and this side is 2. Yeah? Now, well, what's next?
So
No.
all the equilateral lines must be equal.
Yes, very good. All of the, see these 6 triangles here? They're all equilateral as well, because if this is 360 divided by 6 is 60. So each of these here are 60. And this is also an isosceles triangle.
So they're all equal.
So this is also 60.
And this
So
side-
they're all 2s, aren't they? Okay, so how big is this side? 4. And this side?
2.
So that's a 2 and that's a 4. So can I get this one?
Yeah.
Yeah, from
Pythagoras
Pythagoras. So I can say h squared plus 2 squared equals 4 squared. H squared plus 4 equals 16. H squared equals 12. So what's h then? Yeah, decimal. Three point 46 then. Okay. Too easy. Yeah. Right, let me give you some to try now. Okay, yeah. We'll just say 1AB, 2AB, 3AB, and then 4AB as well, and then 5AB. Yeah, we'll just make AB in each. No. The test is everything before the break. Not on the test.
Errors? Like you included all the topics in the street question?
No, but it could be anything. Come on, hey, come on, get working on this.